Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of definite integration. And from today onwards we are starting off with our new series of questions on JEE mains which will be taking from the year 2024 which appeared in January and February tests. So stay tuned for these videos. Let's talk about the question. So if I talk about the question, it says the value of limits from 0 to 1, and the expression which is given to us here is 2x cubed minus 3x square minus x plus 1 raised to 1 over 3 is equal to what? That is the question asked to us. And if I talk about the answer choices, the options are -1, 2, 0, and 1. So we need to figure out which one of the answer choice is the correct answer for the question that is given to us here. Let's try to solve this question further and figure out the answer for the question. Before starting off with the solution, I would first like to tell you that please do subscribe to my channel and support the channel as well, because it takes lots of efforts in making this videos for you on everyday basis, and it is free for you but also motivates me to put up better content and try to make the solutions as easy as possible for you to understand them in a better way. Let's try to solve this question. So if I talk about the question first, I have been given the expression to find the value for that is 0 to 1, and the expression function given is 2x cubed minus 3x square minus x plus 1 raised to 1 over 3 dx. Now once I have this expression with me, first let's factorize this cubic polynomial and let's simplify it, and then we'll put it in this integral. So if I have that, let's simplify this. 2x cubed minus 3x square minus x plus 1. So if I want to factorize this cubic polynomial, we know cubic polynomial, when I have to factorize, I have basically three linear factors, or I can have one linear and one quadratic factor. So basically one linear factor means a power of x raised to 1, and a quadratic means a power of x raised to 2. So that basically combines to give you a cubic function, which is what we have been given here. So if I try to factorize a linear polynomial out of this cubic, what we'll do is we'll try to make the coefficients of the next two terms same as the coefficient of the first term, so that I can take out at least that two common from them. So if I want to make that possible here, what I will try to do is 2x cube I'm keeping as it is. The second term which is there, minus 3, I'll take that as, let's say, minus 2x square, because I want to take two common, right? So if I have minus 2, to make it minus 3, I should have one more x square subtracted. So minus 2x square and minus x square, so minus 3x square. So we have to basically do this manipulation. Now for minus x, again, if I want to arrange this minus 2, I'll keep minus 2x. But since I want minus x, I should add 1x. So minus 2x and plus x makes it minus x. So I'm splitting that as it is and plus 1 as it is. So now if I have six terms, let's try to understand now what it can take common. So if I just rearrange them, because I need to have all my 2's together. So 2x cubed minus 2x square minus 2x and minus x square plus x plus 1. Now let's try to take out some things common from here. So if I am taking out from this something common, and from this I can take out 2 and x common. So you're left with x square minus x minus 1. And from here, if I'm taking something out, nothing is coming out. So I'll take right as 1. So basically you are left with x square. And since you have taken minus common, the signs of everything would change. So x minus. So we get this. Now further, if I try to simplify, I get 2x minus 1 and x square minus x minus 1. So we get this cubic function simplified. And once I have this cubic function simplified with me, I can just write I is nothing but limits from 0 to 1. And you have your parts of the expression as 2x minus 1 multiplied with x square minus x minus dx. Now once I have this with me, let's try to further simplify this definite integrals. So I get integral of a to b f of x dx is equal to a to b f of a plus b minus x dx. So if I use the idea of definite integrals using this property, I can write this further as 0 to 1, 2 times instead of x, I can write everywhere a plus b minus x. So a plus b minus x in this expression is nothing but 0 plus 1 minus x. So you can write instead of x everywhere 1 minus x. So I will just substitute instead of x 1 minus x everywhere. So if I do that, you get 1 minus x whole squared minus 1 minus x minus 1 dx. So I get from here 0 to 1. 2 times 1 minus x, I get 2 minus 2x and minus 1. And the second expression becomes 1 minus 2x plus x squared minus 1 plus x minus 1 dx. Now once I have this, let's try to cancel whatever terms I can do. So 1 and minus 1 gets cancelled. You get minus 2x and plus x, which is minus x. So let's try to simplify this. So I get I 0 to 1, 2 minus 1, which is 1, 1 minus 2x. And here you get x square minus 2x and plus x. So x square minus x minus 1. So once I get this x square minus x minus 1, I have already with me. And instead of 1 minus 2x, we have 2x minus 1. So if I try to rearrange this, I can write that as 0 to 1, minus taken out. So if I take minus out, I can change the order of this term. So 2x minus 1, x square minus x minus 1 dx. So basically, if you see your I minus, if I take it out only of the integral also, you have this expression. And once you have this expression here, what you get here is this entire thing is present, right? So you get your original question turning back here. So what I can write is I is equals to minus, and this entire thing, if I write it from, let's say if I write this as equation 1, so from 1 I can write this as I. And once I get that, if I figure out I plus I is 0, 2I is 0, and that gives you I equals 0. So I get the answer for this question as value of I as 0. And if you see the answer choice that matches here with the question, it is option C. So C becomes the answer for the question that is given to us here. I hope you have understood how to solve this type of questions using the properties of definite integration. I'll see you tomorrow with some other question from some other topic. And we are going to continue this series of questions on JEE mains from the year 2024. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing on everyday basis, please do like the videos as well and do subscribe to my channel and share this channel with your friends also who are involved in the preparation of questions on JEE, so they can also take the benefit from these questions which we are solving on everyday basis. Thank you.